All right, changing gears to offshore aquaculture. The open ocean, the great frontier, is something that we're going to look at now. This is from the National Ocean Service at the Beaufort NOAA Lab. Has a group that does aquaculture siting and ecological impacts of aquaculture, and they've worked a lot with the development of the rules and regulations that are going to govern offshore aquaculture in the United States. And there's all sorts of groups that are that don't care, they just don't want to see it. But, that's them. Blah, blah, blah. So anything offshore is not just fish farming, but any kind of fish, shellfish, seaweed, sponges, lobsters, conchs. Lots of these have potential value and can be cultured out in the open ocean. Some of the fish that have been looked at are cobia. Salmon is the only one that's done at any kind of large scale. This is a yellowtail, and pompano, groupers, red drum are all species that have been considered for offshore aquaculture. Right now, the only place where there is even a preliminary permitting, well, not the only area, but one area that they've now created a framework for is the Gulf of Mexico. But they're still kind of tied up in lawsuits. They basically went through a decade-long process of identifying what they were going to do. They said, okay, we're going to start off with a limited number of sites of a limited size, and had all these parameters, and they're still fighting through the lawsuits. I don't think they're actually moving on any of those, even though there have been a few permits issued. So we've showed you this before, where all the aquaculture is happening over in Asia. But areas where you can have offshore aquaculture are typically areas close to shore with deep water and good current. So the main issue with our coast right here is, what is it like if you start driving offshore? What happens to your depth?
It gets dramatically deeper fast.
It does not get dramatically deeper very quickly. You have to just keep going. It's slow. It's a sort of slow.
What's your idea of deep, I guess?
Okay.
let's set the parameters, right?
Deep being hundreds of feet of water.
Okay.
So let's say you need at least 80 to 100 feet of water. How far offshore do you have to go to get that? Here, you're talking 15, 20 miles. Other places, that's right there, you know, where there's steep gradients. So that's what I meant, is you're looking for some of these 100 to 300 feet of water. Here you have to go pretty far to get to it, out in a pretty exposed environment. But there are areas with, again, good currents and areas that are ideal.
So is that the reason the Gulf is the prime candidate? Because I mean, because the East Coast is like that. That gradual.
I mean, I guess that's one of the reasons that it's just where the framework's been established. There are some other areas off of California is somewhere where they're actually doing it, but basically they have. I think theirs is being done in state waters though, not federal waters, because inside of 3 nautical miles offshore, it's all managed by the state. Outside between 3 nautical miles and 200 nautical miles offshore, it would require federal permitting. I think the stuff they're doing off California is in state waters, and they're working on federal permitting for the Gulf of Mexico, but again, I think the lawsuits have it.
I think another thing that makes it easier in the Gulf is wave height. Because, you know, even the waves on average and during a storm get so much bigger on the ocean, and if there's a storm, you know, you want to be able to drop these things down below where they're bouncing in the waves. And so there's a calculation you can do to say, you know, look at the wavelength, the wave height, and how deep you have to go to be out of the waves. But you probably don't need to go as deep with your cage in the Gulf as you would out offshore here, to be free of that.
And there's also a lot of infrastructure in the Gulf of Mexico in the form of abandoned oil rigs, as far as platforms for these operations. So again, the EEZ, or exclusive economic zone, is that 3 to 200 nautical miles. Finfish are being done in Hawaii with the they call it Kona Kampachi, is their sushi grade Ceriola, or which is a type of jack. We get the same species here offshore. Cobia are being done in Panama. Salmon in Maine and Washington State. Cod are being done a little bit off of New England as well. And sablefish are being grown in off of Washington State up there, British Columbia area also.
What family is that in? Do you know?
The sablefish? No, I don't. Offshore shellfish production. So this is deep water culture of mussels. Blue mussels can be grown on long lines that are basically kind of strung like this off of floating structure out there. The offshore lobster fishery folks have some of them have transitioned to this mussel culture off the state of Maine. There's some other kind of raft type systems or suspended systems for they're doing some stuff with abalone on the west coast, and some of these other shellfish on the Pacific Northwest, and kelp and other macroalgae are being grown off of Maine also. So when people think of developing aquaculture in our water bodies, there's pictures like this, and this is a bay in China, and basically everybody with their little bamboo stakes and all these little fish pens, and everybody's going to work. That's what I think that's the fear and the perception, but the reality might be a little different. So this is a little modeling exercise that they did where they were proposing these. These are some of the cages that you can float up and sink back down, and off of California, the California coast. And I think that people were thinking that, like, oh my gosh, they're going to be doing this right off our coast. It's going to look like this. Well, they could have a program that they can put in. If the cage is 5 miles offshore, which is where it was proposed to be, you can hardly see it on the horizon. So it's same with offshore wind. They've used the same tool for that kind of thing. So how much can we produce? If you look at the country of Norway, they have like 0.1% of the shoreline that we have, and they produce more salmon and other finfish in their offshore waters than except for excluding China, all the other countries in the world. And so we have so much coastline that we have the potential to completely change our whole seafood scene if we were to embrace it, as some of the Mediterranean countries have. Scotland and Ireland are doing it quite a bit. Down in Australia, it's being done. In the Gulf of Mexico, not the Gulf of Mexico, the Gulf of California in Baja, Mexico, is a developing location for more marine cage aquaculture. The technology is something that's coming along. It's hard to develop really high-tech technology when there's not a big market for it. But when you're close to shore, protected areas, you can do a surface cage, which basically kind of floats on the surface. As you get a little bit deeper, you can have a sort of submerged cage that maybe has some more protection over the top. And then there's several different submersible cages that have gone, they've even designed these things that have a really low, they use the wave energy to create a sort of propulsion and steering mechanism where they can, like, you send this thing out into the ocean with all these fish in it, and it like travels the currents and stuff like that, and drives around, has automatic feeders in it, and then comes back to you when it's ready to harvest, you know,
That sounds cheap.
months later. Yeah, do that. We can do that. We got a grant proposal we're going to put in for that. But that's, you know, and they just keep getting, you know, this economies of scale start to come into play. If you're going to build something like that, you might as well build it freaking huge so that, you know, it can pay for itself. Floating cages are often where this all starts. Again, you get those benefits of being able to see your fish and access it, but it is more susceptible to storms and predators and theft and all that stuff. These ships that tend and harvest from the salmon cages are pretty awesome. You know, they'll pull up to a cage like this. They got a hose that they stick in the tank, and it just sucks all the salmon into their hold, and then delivers it to the processing plant. Obviously, predator netting and escapes are a big issue, especially when they're culturing like Atlantic salmon on the West Coast. People worry about that. These are some of the submersible cages. Again, some of them can float up and down. They still do involve, you know, diving for maintenance and everything like that. So there's a lot of cost to it. There's the sea spar is the one that's shaped like this. It's shaped kind of like a cone, a cone and an inverted cone stuck together. You can fill this middle thing with air, and it acts as a float to come up. Those are people on it, so it's very large. What's the name of that dome-shaped one? I forget. There's the, you know, ones that are made out of triangles, ones that are made out of hexagons, ones different styles and cages. Same idea. These one just uses simple airbags to float up and down. So when they start developing a site, they actually look at it now as, all right, we got to keep all this stuff in place. They have mooring fields and gear lines and all that kind of stuff. And so for 12 acres of cages, you need 90 acres of space so you can have the right mooring system in place. And then you don't want that to take up your whole lease, so they actually expect you to not use the entire lease for that area. So where this becomes an issue is making sure you're not interfering with, you know, shipping traffic and all that kind of stuff. So that's where the siting becomes really important. Okay, so yeah, Norway uses 1.1% of their EEZ, and they produce 1.3 million tons of salmon. So if we were to use 0.1% of our shoreline, we would be able to produce, you know, billions. Talk about shellfish. So the other thing in offshore cage culture, one of the problems there is, again, you're feeding and the wastes are just falling out and going down and creating issues. Early on in cage culture, when they began farming salmon in like these protected fjords and bays and areas where their surface cages wouldn't get damaged. Well, all the waste just fell down to the bottom in one compacted area, caused low dissolved oxygen, high bacteria problems, disease issues, all sorts of bad things that people think about salmon farming happened because the initial siting was not well informed. Now they move into areas where there's a lot more deep water and higher flow, and it eliminates some of those problems, but you do have nutrients that come out from your ammonia production and that kind of thing. And you have waste, solid waste from the fish and waste feed that falls through the cage. So this IMTA, or Integrated Multi-Trophic Aquaculture System, is finding things that you can grow on that waste, like sea urchins, sea cucumbers, that kind of thing, as well as taking your increased productivity from your higher nutrients and using that to grow shellfish like mussels and macroalgae like kelps and stuff like that. So they kind of have the proof of concept for this. They've done it in Canada and other places, and it's starting to be incorporated into lots of types of aquaculture production. But this is a way to, diversify your products that are coming off your farm, as well as make the most out of your feed and reduce your environmental impact. So the science that goes along with trying to figure out what goes on here is another whole thing that's going to go along with any kind of industry development that happens in the United States. And again, people have big dreams to combine this kind of technology with offshore energy production and those kinds of things in our underwater worlds that we're going to live in soon. Any questions about offshore production? All right.